Okie dokie. Let's talk about how to irrigate. So, you are growing crops, you're farming, but you're going to need to add some water a lot of times. So, what is irrigation? You're artificially applying water to the soil. You can use a number of things. You can use pumps, sprays, channels, and usually you use this where you don't get regular rainfall necessarily, or during droughts. Although a lot of places will have, a setup for irrigating their crops unless they're in like a particularly rainy area. The source of water can make a big difference as to the impacts of the irrigation technique. So you can get this from groundwater, meaning underground, like aquifers. You can get it from springs or wells, which also take from groundwater, or you can get from surface water. There's some places where they use treated wastewater or desalinated water, depending on how much availability they have of water. Irrigation is extremely important because it is our largest use of fresh water. So 70% of the fresh water that humans use is used for irrigation for growing our crops. So let's talk about the different methods of irrigation. Kind of the old school, oldest method of irrigating is flood irrigation. Usually you use series of channels to bring water from whatever water source to your field. Sometimes you flood it, sometimes you're just watering it a little. You can use levees and gates to control the water depth and control water entering. Um, flooding irrigation, where you have the field kind of flooding, is a little more used for rice and alfalfa. We're going to talk about a subtype of flood irrigation in a moment as well. So, what are the advantages? You don't need a ton of technology, and it's powered by gravity, so you don't need an external energy source. What are the disadvantages? Well, you lose a lot of water to evaporation and runoff, so it's inefficient. It would only be useful in places where water is very plentiful, but another drawback is it can cause waterlogging of the soil, which we'll talk about a little later. A subtype of flood irrigation is furrow irrigation, where you cut these furrows or trenches and then you allow water to flow down them. So it directs water, it's not just kind of flooding across the field in a giant sheet. So these trenches get filled and then it can end up watering your plants. Just like with irrigation, it is inexpensive, it's low technology. Honestly, you could do it with a shovel if you really wanted to, just would take a lot of time and effort. And then this is also powered by gravity. Now, obviously, if you don't have a source of water that's higher up than your field, you may have to pump water there. But to spread the water throughout the field, you're mostly relying on gravity. Unfortunately, very similar to flood irrigation, you're losing a lot of water to evaporation and runoff. That's about a third of the water that you put on is going to evaporate or just run off to the nearest water source. And then another thing, you have to have your land pretty level. If you've got a bunch of hills and bumps, the water's not going to flow over those hills. It doesn't flow uphill. And so you're not going to be able to as effectively spread the water over the surface of whatever you're looking at, whatever field you have. And then in sandy soils, it's inefficient because sandy soils have a high rate of infiltration, meaning instead of the water spreading out over the field, it just sinks down into the ground. All right. Then what's probably what you're most familiar with is spray irrigation. My bad. You use spray nozzles to spray water through the air to water your field. This is, sprinklers as well for people watering their lawn. Advantages, you can be more efficient and use less water than flood and furrow irrigation because you're not trying to flood an area. But there are problems. You are going to lose about a quarter of your water to evaporation and runoff. It's more expensive because you have to have, a sprinkler system installed. You may have to have tubes to carry the water. And then you're going to need energy because you're going to have to usually pump the water so that it will come out the nozzle. So you might need, to use electricity or some other form of energy besides just letting gravity do the work for you. The most efficient type of irrigation is drip irrigation. It uses perforated hoses, meaning it's got holes in it. to release small amounts of water directly on the plant roots. So here you have an image of drip irrigation. You have to have tubes set up, and then you have holes in the tubes, and that is what allows water to come out. Usually this is fairly low to the ground. That way you don't lose a lot of water to evaporation. So this is the most eco-friendly, water-conservative method of watering your plants. You only lose about 5% of your water to evaporation and runoff. Also, it reduces nutrient loss from your soil because when you have like soil and then you have water passing through, it's going to pick up nutrients along the way and it's going to carry that with the water. And that process is leaching. And so that can decrease the amount of nutrients you have in your soil. And I saw some setups when I was researching for this where people added like liquid fertilizer, like, fertilizer, the compounds that you have in fertilizer to the water before irrigating, so then you don't have to separately apply fertilizer. But the big disadvantage is it's expensive. It's expensive to set up, and then you have to maintain it, meaning you have to make sure that nothing's coming along and damaging your tubing, because if it does, you're going to have a leak and your water's not getting to the right place. So for example, I have wanted to have drip irrigation um in my yard and for my plants for a while. However, like I said, it's expensive. I could hire a company or I could set it up myself, but I'd still have to buy all the equipment. And so it also takes time to set up instead of just setting a sprinkler in the lawn. And not that I use a sprinkler, I just let my lawn die in the summer. Um, but it's going to cost a lot of money. So if you're a farmer, if you're a subsistence farmer, you're probably not going to be doing drip irrigation. So let's talk about what happens to the environment as a result of us watering plants. Unfortunately, if you give a plant too much water, you can actually, um, I don't know if you know this, you can overwater a plant. I have done it. That is why I am plant death made human, because I kill lots of plants accidentally. And so what happens if you put too much water onto the soil, it can waterlog. So when you have rain or irrigation coming down faster than the water can drain out through the bottom, it becomes waterlogged. And what's big problem is when this causes the air pockets around the roots to get filled up. So this creates anaerobic conditions, meaning no oxygen. And root cells of plants need oxygen just like every other cell of a plant needs oxygen. So this can also raise the water table. And then you can't absorb oxygen through the roots, and that can lead to some toxicity. You can have nutrient deficiencies if they're not able to absorb properly, root death, and reduced growth or death of the plant. There are some plants that are adapted to waterlogged soil, but those would be plants that are usually found in wetlands, and we don't tend to really raise those as crops. The really big problem is salinization. Salinization, have you ever heard the phrase salt the earth? Back in the day, if somebody made you really, really angry, um, or an invading kingdom, and you just wanted to destroy the people you were invading, you could salt the earth behind you. And if you salt the earth, nothing will grow there for a long time. So when your soil is too salty, it's bad for the plants. What can happen with irrigation is if you have, water that you're putting on in the soil, it can dissolve salts from like deeper in the layer of soil, which can then rise up, diffuse through the water, and then spread throughout the soil. Another thing is if you have salts dissolved in your water, those salts will be left behind when water evaporates, and either of those can cause salt to build up in the soil. Once that happens, once you have a high enough salinization, that soil becomes toxic to plants, and it can take decades to get enough of the salt out so that way you could be able to grow things there again. So salinization is a really big problem in some areas where, if the soil is becoming too saline, you can't grow anything there, and that makes us lose viable farmland, which reduces food production, which can become a problem. although some people are trying to either genetically engineer or breed plants that can tolerate higher salinity. And then a big problem is when you don't have surface water, a lot of people will use groundwater or aquifers. Unfortunately, aquifers recharge, which is the rate at which they refill, pretty slowly. Some of them will take hundreds of years to recharge. Some of them can take thousands of years to recharge. And so it's very easy to take water out faster than it can be replenished. If that happens, you deplete the aquifer. And once you deplete it, you can have all sorts of negative consequences. One big one is you just don't have a water source. So this map right here is showing you the Ogallala Aquifer in the central United States. So here's Texas down here, here's Oklahoma, here's the Texas Panhandle, there's the Oklahoma Panhandle, and you can see it going north. Now, areas that are like dark red are areas where the water has been depleted, like the level change has more than 150 feet decrease in the water level in those areas. So those are areas where they've pulled a lot of water out of the aquifer and it's not recharging fast enough. So the aquifer is depleted. Then you had farms in that area that are no longer able to be supported because they don't have a good water source. And there are some areas though that aren't affected. There are even some areas in like I think Nebraska which have an increase in the level of water, but not 100% sure why that happens. That's a lot rarer than having aquifer depletion. Another thing is when you have water that you're taking out, if that leaves like a lot of holes in the stone behind, then you can have sinkholes where basically the ground caves in because there's no water. And then you have these giant, it's like a pothole on steroids. They're huge, things can fall in them, they can damage roads, damage structures, and so that becomes a really big problem. So, the best thing to do is put like regulations into place. This is an example of tragedy of the commons. It's a common resource. Everybody shares an aquifer. Nobody owns an aquifer. And so it's very easy to say, okay, I'm going to get as much water out of this aquifer as I can. So those are irrigation methods. We'll continue on with some more notes about farming while we continue on with other things in class.